This is Carrie Rasmussen, a food safety specialist from CFS. In this module, we will complete the remaining items on the equipment design checklist. Continuing from the previous session that elaborated on principles 1 through 5, we will take the same approach and focus on the remaining checklist principles. Checklist principles 6 through 10 contain quite a bit of information. While there is much more detail within each principle and sub-principle, we will extract and highlight some common concerns from them impacting equipment design. You will see that many of these principles overlap. Whether classified in another category or not is inconsequential. Understanding and addressing design flaws is the end objective of any hygienic design checklist. One of the more inclusive design principles references niches, which are locations where microbes can reside, propagate, and disperse into other areas, including product contact areas. Niches are difficult to access, making effective cleaning difficult to achieve. These niche areas can include pits, cracks, and corrosion, which may occur gradually or built-in design gaps, including seams, gaps, lap joints, ledges, threads, bolts, rivets, and dead ends. Lap joints in equipment are common and refer to an interface where surfaces overlap, often visualized as a sandwich. The image on the right is a flip-up conveyor, and as often is the case, the original idea was operationally a good one. However, execution from a hygienic design standpoint was flawed, because the hinged area has an excessive number of lap joints created by the bolts. Why not just weld the interface and eliminate the bolts? Fewer lap joints lead to less harborage and easier to clean areas, resulting in lower risk. A lap or sandwich joint describes joining two pieces of material by overlapping them without a hermetic seal. A hermetic seal is airtight and does not allow for any contamination. The upper image shows two sandwich areas. One is between the screwed-on plastic guard against the stainless steel frame, and the other is between the two stainless horizontal pieces that make up the stainless steel frame. If one looks critically, lap joints are prevalent in a great deal of equipment, especially older units when design principles were not always top of mind. The lower images illustrate a flush-mounted bearing that contains a sandwich joint. The image on the right is an improved design that provides access under the bearing mount by using welded standoffs. Lap joints can be in multiple areas and present access and cleaning challenges wherever they may occur. Often, the more you look, the more you will find. All joints and welds are flush and free of pits, cracks, and corrosion. Otherwise, they can become a niche. Pictured are examples of welds that have excessively rough surfaces, pitting, or voids. In the picture on the left, poor welding was done many times on the equipment. A question that should be asked is, what is causing the stress that is breaking the welds? We should address the root cause as the first step. The picture on the right shows non-continuous welding above a product area. Not only is the welded design unnecessary, a hard-to-clean spot is created behind the plate. A different design could have eliminated these welds and avoided creating a hard-to-clean spot. All welds are smooth and continuous. Both images are examples of problematic welds for CIP, which is clean in place, cleaning, which can be found in pipelines. In the left image, stainless piping is welded with an inert gas purge, such as argon, for sanitary welds, which are common in pharmaceutical and food, particularly dairy, industries. Stainless steel oxidizes quickly at elevated temperatures with the gas purge. This causes a non-sanitary oxidized weld. In the image on the right, if the weld is not fully filled, microorganisms could become trapped in the unfilled crevice, resulting in a cleaning challenge that will likely promote a product shelf life or spoilage issue. Sanitary welds take craftsmanship and care, which are critical to installation processes. Assemblies, such as bushings, sprockets, and bearings, are disassembled or accessible for cleaning. Otherwise, there will be a niche area supporting growth. The left image shows hollow idle rollers. When disassembled, water, films, and soils are visible, indicating these are harborage locations. The right image shows a free rotating hollow and feed roller rotating over a stainless steel shaft on a slicer. Water and microbes can become entrapped, which are not effectively cleaned and can shed into a product stream during operations. Design is not only essential to cleaning effectiveness, but impacts operational performance as well. Contamination can occur at any time, and while sanitation issues accelerated by poor design is often a root cause for contamination events, poor design can lead to sanitary operational issues as well. In the left image, air blowing from a tube that is not accessible, easily disassembled, or designed for cleaning becomes a harborage area that can lead to product contamination through airborne contaminants. In this case, these long tubes are homemade air knives for blowing pieces of product, and the air is not filtered. In the right image, excessive lubrication can lead to chemical, physical, and microbiological contamination. Bearings containing lubricant located directly over a product takeaway conveyor, as is the case in the photo on the right, is a problem waiting to happen, particularly if overgreased and poorly maintained without a catch pan. Maintenance enclosures and HMI screens must be designed to ensure water or debris does not penetrate and accumulate in interior cabinets or housings. They have been known to harbor or shed microbes into processing environments. This image illustrates different designs and the evolution of buttons and control panels. Today's COVID environment places additional emphasis on this sub-principle. Starting with the image on the left, these buttons are difficult to clean and maintain. The middle image shows progression to a smooth and easier to clean control panel. However, this design must be cleaned with limited moisture by hand. The image on the right is a full wet wash control panel, rated at IP69K, which is high pressure and temperature rated. Wires and conduit, if not separated, can become harborage areas which cannot be accessed, separated, or cleaned. Pathogens can and do reside in these often neglected locations and can be attributed as a cause of contamination. Bundling, as you can see, is often accompanied by use of zip ties, which can be neglected and turn into foreign material hazards as well. Wire trays can also collect water and debris, and the question must be asked, how do these areas get clean? Design should not be limited to a specific piece or group of equipment, but consider the entire manufacturing asset, including support equipment like exhausts, utility, and sanitation support. If improperly designed or installed, unintended hazards could occur. Exhaust systems are examples of asset components that must be designed for both ease of cleaning and sanitary operational performance. Ductwork, as shown in the slide, requires access and cleaning. Exhausts should not be allowed to cool down and drop into product streams or processes. Once equipment and supporting systems are designed, installed, and operational, cleaning and sanitizing protocols need to be developed and validated for effectiveness. While sanitation processes are important considerations prior to purchase, validated cleaning in conjunction with associated and necessary chemistry, temperature, utilities, and supplies are essential to ensure that consistent execution will lead to sanitary conditions. In summary, equipment design principles should be carefully considered prior to purchase, during installation, and throughout manufacturing. Although there is no perfect equipment, careful consideration of all the hygienic design principles will lead to effective and efficient sanitation and increased operation time. Hygienic design has an impact that can last for many years, so you should educate colleagues and communicate early and often. Thank you for joining us in this short course about hygienic design as a choice. If you have any questions, please contact us at training@cf-san.com or visit us on our website at www.commercialfoodsanitation.com.